0.6 milliliter of acetic acid having density 1.06 gram per milliliter is dissolved in 1 liter of water. The depression in freezing point observed for this strength of acid was 0.0205 degrees centigrade. Calculate the want-of factor and the dissociation constant of acid. Now freezing point depression is equal to 0.0205 degrees centigrade. Now this is the experimental value. Volume of acetic acid is given as 0.6 milliliter and density is given as 1.06 gram per milliliter. So mass will be equal to volume into density. So this is equal to 0.6 into 1.06. This is the mass of acetic acid. Moles of acetic acid will be equal to weight of acetic acid, that is 0.6 into 1.06 divided by molecular weight of acetic acid. Molecular weight of acetic acid is 60 gram per mole. Solving moles of acetic acid is equal to 0.0106 mole and let this be N. Now what is the formula for molality? Molality is equal to number of moles divided by weight of solvent in kg. Now solvent is water, volume of water is given as 1 liter. Density of water is 1 kg per liter, volume of water given है 1 liter. तो weight of water क्या हो जाएगा? Weight of water क्या हो जाएगा? Volume into density, that is 1 into 1, तो ये हो गया 1. तो molality of solution क्या हो जाएगा? Molality of solution हो जाएगा moles of solute, that is 0.0106 divided by weight of solvent in kg, तो divided by 1 हो गया, तो मोलालिटी हो गया 0.0106 मोल पर केजी. अच्छा, डेल्टा TF इज इक्वल टू KF इंटू M. KF फॉर वाटर इज 1.86 केल्विन kg per mole. Molality is 0.0106 mole per kg. So delta TF, calculated value of delta TF is 0.0197 Kelvin. Now what is want of factor? Want of factor is observed freezing point divided by calculated freezing point, or experimental freezing point divided by calculated freezing point. Experimental value of freezing point depression is 0.0205 Kelvin, which is given in the question, and calculated value of freezing point depression is 0.0197 Kelvin. So experimental value of freezing point depression divided by calculated value of freezing point depression is equal to want of factor, which is equal to 1.041. Now acetic acid is a weak electrolyte. So writing the equation for dissociation of acetic acid dissociates to give H plus and acetate ion. Now initially N moles of acetic acid was present and amount of H plus ion was 0 and amount of acetate ion was 0. So if the degree of dissociation is X, degree of dissociation means amount dissociated out of 1 mole. So if degree of dissociation is X, means out of 1 mole, X moles of acetic acid dissociated to give X moles of H plus and X moles of acetate ion. So amount of acetic acid left is, if initially 1 mole was present, then amount left after dissociation is 1 minus X moles, and amount of H plus ion formed is X moles, amount of acetate ion formed is X moles. So out of 1 mole, amount of acetic acid remaining is 1 minus X moles, amount of H plus ion formed is X moles, amount of acetate ion formed is X moles. This is out of 1 mole. So if in the starting N moles of acetic acid is present, then amount of undissociated acetic acid present out of N moles will be N into 1 minus X, H plus ion present will be NX moles, and acetate ion present will be NX moles. So total number of particles after dissociation will be N into 1 minus X plus NX plus NX. So total number of particles will be N into 1 plus X. So value of I will be number of particles for dissociation divided by number of particles for no dissociation. So n into 1 plus x divided by n gets cancelled, and value of I is 1 plus x, and we know the value of I. So 1 plus x is equal to 1.041. From this, value of x will be equal to 0.041, Amount of acetic acid remaining is N into 1 minus X. So putting the value of N and X, we get the amount of acetic acid remaining. Amount of acetate ion is N into X. So this is the value of N multiplied by X. Amount of H plus ion is N into X. So this is the value of N, this is the value of X. Value of Ka, acid dissociation constant, is product of the concentration of products. The product is acetate and H plus ion divided by the concentration of reactant, that is acetic acid. Putting the value for the concentrations of acetate ion, H plus ion and remaining acetic acid from equation 1 and 2, we get value of Ka is equal to 1.86 into 10 to the power minus 5.